we're going to start to work with application. So I'd like you to grab your calculator, because you'll need to use your calculator probably for most of the remaining questions from the application component today. So this first question here doesn't really need a calculator. So just if you have a moment, what's 5 cubed? Whoops. Can you hear me? Thank you, Anthony. Okay. Now, these two questions here, actually these three questions here, are just to make sure that you're competent to use certain features on your calculator. So just take a moment and see that you can do this calculation on your calculator. So what would be 5 to the negative root 3? This is more like getting your driver's license on your calculator than anything. Anybody have a number there? You should get this number on your calculator. If you don't get this number, then make sure you're using the brackets correctly, because you do need to know how to use these features on your calculator, as it could be very bad if you get something wrong and they're not really in part marks. Okay, how about 2 to the pi? Does anybody have a number for 2 to the pi? Anybody have a number for 2 to the pi? It's so quiet. Yeah, that's a good number. Thank you, Jai. Thank you, Jason. And what about this one here? This one's trickier. It's depending on your calculator, you might not have the button as nice as other people. Just make sure that you get the following result on your calculator. I'm just going to put the answer there. Make sure that you get this on your screen, because you need to know how to use the button E. If you can't find the button on your calculator, it should be where the button called log is. So look for this button on your calculator, LN. You'll probably find the button E. They go together. They're inverses of each other, or they're related to each other. We'll discuss that today as well, actually. But look for the button LN if you can't find the button for E. And they're usually they're on the same button with a shift or something. And once you've mastered that button, then you can do these other calculations here, which I'll just state the answers. If you're wondering what is E, E is like pi. It's a special number in math. It's roughly that. E is 2.718 approximately. Just like pi is a special number. It's 3.14159. You can go on all day. It goes on forever without a pattern. The same thing with E. E is just a special number that is like this. And if you think pi is really important in math, as you can imagine, especially in geometry and trigonometry, well, E is just as useful. When I put E to the power of E, it shows an error. Okay, so Anthony, your calculator, what calculator do you have? Is it Casio? Sharp. Yeah, it depends on the model of the calculator. You might, yeah, all these calculators are different. So let me see here. Casio Advanced. Hang on a second. Okay, so I'm looking at the Casio right now. Okay, I'll do the Sharp as well. Sorry, Anthony. The Casio one, you have this one. Okay, yeah, so for this calculator, there's two different E's. There's this E right here. It's this E right here. There's also another E somewhere that's red. See the one down here? So this is who's this? Who am I helping with this one? Is Max. So Max, see that one there, that red E? See that one there? Yeah, use the red E. You can use that one, okay? And then you hit alpha, and then you hit E. Thank you, Irvin. Now, by pushing alpha, I hit alpha E, and then it's just like a variable I or something. It's not a variable; it's a constant. So the person that first asked me was Anthony. So Anthony, let's talk about Anthony here. So Anthony has the Sharp Advanced Cal. I haven't used one of these, so let's take a look together. It's right here. It's right here, okay? So hit second function E, and then I think you just type the number and you're good. So Shaquille, try to do question 36. I put it in twice shows error, Anthony. Then you gotta do what Jai said. You gotta do this. I'm gonna steal Jai's answer. You gotta do that. I'm pretty sure. Okay. Yeah, the Sharp calculator doesn't have two different E buttons, but the Casio does. Yeah, unfortunately. Okay, so who's still not being able to get it working? And someone in the chat who can't figure it yet. What do you got, Jordan? What calculator? I have both. What calculator do you have, Jordan? Which calculator do you have, buddy? Oh, use the Casio, Jordan. It's easier. Use the Casio, okay? So for the Casio, what you want to do is type the alpha, and then you see down here where it has a red E. So that's how you do it. That's how you get E on your screen. That's the easiest way. There's another button here, but I don't like it because it's weird. Yeah, it's more difficult with Sharp. The other way will work, Max, but it's hard for me to do it virtually because I don't have the calculator to physically show you. You're better off with the alpha. You're better off with this one. Just trust me. Because for this one here, you have to type like E2 if you want to say E to the 2. Yeah. Okay, so let me explain that here, okay? Which calculator are you using, Jordan? Tell me which calculator, because I can't help you otherwise. Casio. Which Casio? This one? Which Casio? What's the model? Jordan? Which one? This one? Okay. What you got to type is this. Let's do question number, this one here. See 1.72? This one here? We're going to do this one together, okay? Okay, what you do is you type in this. Type this in. Shift. Type shift. That button there. And then just type 1.72. Do not put any other symbols. Don't put this symbol here. Do not use this symbol. So don't put the power. Shaquille and Jordan, do not put the power. You got to type this. Look at my screen. You got to type E 1.72. The same way you see it on my screen. No spaces. Don't put this symbol. Do not put the power symbol. You just type that. The way you see it on my screen, that's what you type. Okay? Sorry. No, because 37 screwed up. On that calculator, 37 is really messed up, guys. For 37, if you have the sharp, you got to put EE1. It's really annoying. Thanks, Jordan. Okay, you got that, Shaquille? For 37, you got to put EE1. It's really dumb. Don't blame me. You got to blame the engineer that did that because I hate that feature. That button is the worst button. It makes no sense. Anyway, let's go to question 38. I'm just going to give the answer to 38. I'm not going to, I think we should move along now, but I'll put it here. Now that you got 37, 38 is just like more of the same. This one here, if you have one of those calculators that's really annoying, do it in baby steps. So just do pi minus c first, write down like 5 decimals, and then do this. And that goes for everybody. If you're having an issue typing it on your calculator, remember that E is just a special number that you can look up somewhere. So if any of your calculators are being annoying and you're giving you a headache, there's a number for E, and you can just copy it, okay? It's just this, it's like pi, you can look it up and you can put a bunch of decimals. Anyway, we're going to talk about, I mentioned that we're not going to do any graphing in this class for today's lesson. But you can see here that if you want, you can graph exponentials. This is something that you would have done in grade 11. So back in grade 11, you learned how to graph these. And when you do that, I'm gonna copy and paste the answer right over. This will be posted on Blackboard today, so don't worry, I'm not gonna surprise anybody here. Oops, I lost the picture. Oh, that's the problem. There we go. All I want to point out here is that when you do graph it with a table of values, the graphs have this behavior. So whenever you see a graph that has this this rapid growth on one side, but on the other side it's decaying to 0, then what you have is a basic exponential function. And I've shown 2 of them here, which are 2 to the x and 3 to the x. The reason that I showed these graphs here is so that you understand that exponentials, as you see, these exponentials, they do not produce negative answers. The y value is always positive, unless you apply a transformation. However, we're not doing transformations in this course. So that's the thing I want you to take away from this. You will not be asked to graph functions, as I mentioned earlier, for this course. I'm focused more on the application and problem solving. So what I'd like to do, speaking of application and problem solving, is take a look at question 40 and 41, which are application questions that set up the foundation for some harder questions that we'll do next week. So 40 and 41 are relatively easier questions, but we need them because we're going to revisit them next week when we take a look at more difficult variations to them. So let's take a look at number 40. So here we have the Gateway Arch in St. Louis. So has anybody ever been to St. Louis? Who's been to St. Louis? Nobody? Okay, I haven't either. So they're talking about this thing over here. This thing here, if it'll surprise you, it actually is not a parabola. This thing here is not a parabola. You know what else is not a parabola? This one here will shock you. I'm gonna take an image of it. It's actually pretty cool. It's let me do that cat. You ever had to wait in line somewhere? Or maybe you've seen one of these before? That's just like a rope. Think of like when you're waiting in the bank or something, or if you're waiting outside a restaurant, you have to wait in line there. You know these things that hang like that? Well, this is more of a barrier to a road. But these guys here actually are they're actually mathematically very similar. They're not parabolas. I keep on saying that to you. So anyway, they're not parabolas. Well, the difference is right here, Shaq. That's the formula. A catenary has this formula. Write the formula here. That's the formula for it. It has nothing to do with parabolas. A parabola, as you know, is x squared. Does that formula look like it has an x squared in it? Is there an x squared in that formula? Hell no, right? This formula here is exponential. It's exponential. So if you want to see the formula for the St. Louis arch, it's right here. Look at it. Look how pretty that is. See, you got the e to the something. You got e to the negative of the same exponent. Let me zoom in there. See, you got e to the something, e to the negative. You got a number in front. Now, okay, this one here, I've applied a constant a. You could also do translations. Like for this one here, the negative means it's upside down, and the 230 means that it moved up. I'm not doing transformations with you. I just wanted to point that out to you that there is a mathematical template for all of these types of shapes. So the next time that you see, because as you can tell, this type of shape here is very common in construction. When you have a rope or a cable that's hanging, imagine a cable or a rope. This could be a cable here, and it sags as it hangs sideways like that. That shape is not a parabola. So it's interesting to see that. Although You could model it with a parabola, and it would be close, but it would not be perfect. So let's answer the first question. Yeah, so Jason, the chains actually would not be polynomial. It turns out that in actual mathematical reasoning, it actually turns out to be exponential. And the mathematical reason is far beyond the topic of parabolas. It has to do with some very advanced calculus. If you it's a difficult one for me to discuss at this level, but if you have background in calculus, it's something I can definitely talk to you about in like a separate conversation if you like. It's yeah, it's not a parabola. It's actually a very complicated question. But the point that in terms of getting back to what we're talking about for the lesson only, um, it's not parabola, but it is an exponential, and this is the formula. All I'm asking you to do for this question is process the formula. So it says here, find the height of the arch at the center. Now, the center of the arch is at 0. So, whoops. So the center of the arch is at 0. I can't even teach it the Canadian spelling because it doesn't allow me to add it. If I try to add to the dictionary, it complains. You gotta love that. So anyway, there's the answer to the first part. I'll just stick it right there. So what I did here was I just evaluated the height at 0. So if you substitute 0 for x, over here you're going to get e to the 0. The 38.9 goes away because it's 0 divided by 38.9. And then you get also again e to the 0. So at the center of the arch, look at that height. Look at how impressive that height is. This thing here is 192 meters tall in the middle. Can you visualize that? 192 meters. Like if you lay that thing out sideways, an Olympic sprinter might take them almost 20 seconds to run across from the bottom to the top if you laid it out flat on the ground. Isn't that insane? That thing is so incredibly large. Actually, it turns out that it's just as tall as it is wide. It's one of the architectural features of it, but the width of the arch is roughly the same height as the arch. It's an interesting thing there. And if you haven't gone there, and it's actually on a bucket list for me too, for some people maybe too, you can actually go inside of it, and there's elevators that take you to the top of it, which is pretty cool. So I guess one last thing is, do you know why it's called the Gateway Arch? Why is it called the Gateway Arch? Anybody know? No Google, no cheating. The two ones just substituted for the e. Yeah, because e to the 0 is 1. Jordan, e to the 0, anything to the power of 0 is 1. Sounds good? You're welcome. Yeah, so anybody know why it's called the Gateway Arch? Yeah, actually, that's a good point, Max. It does frame the city nicely. It acts as a gate. Mohammed, yeah, that's actually what it is too. It's like the reason is historically St. Louis is considered the gateway to the West. So think of the United States; it's very large, obviously, and St. Louis is kind of in the middle. So we say it's the gateway to the West, or it's said that it's the gateway to the West. Yeah, that's right. Exactly, the river. Well done. Yeah. Anyway, now, honestly, we should get sponsorship for this video. If I post it online, we're gonna get sponsorship from St. Louis Tourism. We're killing it here. We're like totally advertising St. Louis. As long as the Leafs win, I don't care. They can have their arch. Okay. Anyway, in the next question, Class trip. I think we should. We should get some funding for that. It says here, find the height of the arch at 10 meters. I think Joseph and Max are on a very important point there. We should definitely do a class trip to St. Louis. I feel what you're saying. Sadly, we got to do more math right now. Once COVID is over, there's going to be a lot of partying. I'm telling you that. Anyway. Whoops. Okay, there you go. So it says here, find the arch at 10 meters. So what you see is that instead of 0, that's true, Peter, as long as it's a Leaf game. Enterprise is the hockey arena, am I right? I forget. Yeah. So, oh, here we go. Okay, so you got to plug in 10 for x so that you can get the height of the arch at 10 meters. So this question is really just a calculator exercise. I want you to really take that to heart, people. This question is just an exercise using your calculator. And hopefully you see why I got you to play around with the button E and pi earlier. So if you're having trouble typing this question, the best advice that I have for you is break it down into pieces, just like I did. See this E here to the whatever, 10 over 38.9? I got a number for that. I got a number for that. And I just kind of, scaffolded and built the answer slowly. Nobody's asking you to type the whole thing in one step, although you are able to do that on most calculators. I would recommend that you just break it down to baby steps like I did. So we're off to do question 41 now. And this question is very important for your program because you're dealing with finance. So if you don't mind, I'm gonna slide over the St. Louis question. Let's go back to business here. The question 40 was more of, I guess, just showing you what it is to know how to use the calculator and apply a formula. And now we're talking about finance. The answer for 40 is right here. It's 190 meters. 190.6. Thank you, Mohammed. I'm glad that it worked, Shaquille. After the suffering we wanted to get everybody's calculators in the right place, or people in the right place with their calculator, I'm glad that it worked out. So question 41 is a finance question. Again, somewhere back in the day, most likely in the Ontario curriculum at least, you would have done this in grade 11. So when it comes to questions involving finance, I expect you to be able to build a formula for compound interest. So if I say here $5,000 and the rate is 4.2%, this formula here, you may have to create it yourself. Now, if on your final test I have a finance question, I would warn you in the announcements prior to the test that you should know the formula for compound interest. Anyway, we're going to cover these examples here, but let's talk about formulas briefly first, because I said that you need to know that formula. So if you go to the notes on page 4, this is our booklet on page 4, I've made a very comprehensive list of applications of exponential and logarithmic functions. So we have here finance, we have seismology or earthquakes, measurement and study of earthquakes, physical science like doubling and half-life and tripling, and then finally some chemistry. These are ones that in construction management you potentially might encounter depending on what your specific focus is. However, for this course, if you do get a question involving formulas like this, I will give you the formula. If it's any of these things here that you see, I would give you these formulas. Now, where it says seismology not on test and chemistry not on test, this is notes based on in class before COVID. But if I do intend to give you a formula on a test, everything is fair game. I would give you the formula. The only formula on this entire booklet from this page, that I need you to know is this one. You are responsible to know how to use this formula. Right there, okay? So I'm making an important note there. You need to know how to use that formula. You use this formula in grade 11. If you studied in Ontario, it would have been grade 11. Otherwise, who knows when you studied in high school? Maybe it was earlier, but for sure, most high schools, they teach it in most countries. So anyway, we're going to go back here and take a look at 41. In this case, the formula is actually just given to you. That's fine. And the question here is to find the value of the investment after 5 years and 20 years. So when you invest money and interest is compounded, you expect it to grow exponentially over time. Just like those graphs that I showed you earlier, the money will grow like this. So I'm not asking you to graph it here. I just want you to tell me the value for the investment after 5 years and 20 years. So I've already done these calculations before, and I'm just going to plop them in here for a second. So there's part A. So you can see here what I did was I put 5 and I put 20 for time. Part A and Part B, I don't expect too much friction with the students today because it's not too dangerous of calculations. You're just plugging in a number. And Part B is more about getting you familiar with the formula. Let's take a look at Part B. In Part B, we say, what would the general formula be if the rate of return was different? Part 1, because it says 5 years, Shaquille, right here, after 5 years. And then a 20 for the other one. So for Part B, we're looking to modify the formula as needed. There we go. Okay, so how would the formula change for the other ones? Well, the interest rate's changing, so we would see the formula have a different base. Excuse me. Thank you, Max. I think I'm allergic to mathematics. It's not a good thing. No, you guys are fine. Okay, anyway, so there's the formulas if you modify. So you see, if I change it from 4% or 4.2% to 7.1%, then the base changes. If you go to 13% there, and if you have 9.07%, you got that. So that's just this is having like an opportunity to practice manipulating the formula. The question that I'm most interested in is part C. So the title of this booklet is Exponential and Logarithmic. I have not talked about logarithms at all at this point. But this part C is a motivation for why you would want to learn logs. I guess the word need is a bit heavy. You could say here want, maybe, because you don't need to know logarithms to do math. But anyway, let's talk about part C. It says here, how many years to get to 17,000? So let me hammer this one out with a keyboard. So you would set the money equal to 17,000. You get that? Now, how do you solve for t? Well, the first thing you want to do is divide both sides by 5,000. And when you do that, what happens to the 5,000s here on the right side? What do you get on this side? Anybody? What do you get on the right-hand side? Yeah, thank you, Jai. You get that. So now the question is, how do you solve this? So thank you, Siddharth. So how do you solve that? Well, I'll show you three possibilities, okay? There's three ways that I can think of. Method 1, you guess. Method 2, you graph. Method 3, logs. Those are the three most popular methods to solve this, okay? The first way is you just guess. You know, like when you're someone's birthday and you say happy birthday and you go, are you 1, are you 2, are you 3? You do that until you get to what you need. Just guess the crap out of it. Are you 1, are you 2, are you 20, are you 30, whatever, okay? You keep on guessing. Method 2 is that you graph it. So you graph this one, and then you graph that one, and you see where they hit each other. And then you find what value of t is. But method 3 is the least invasive one in terms of guessing and wasting a lot of time, because I don't want to graph. You want to graph? I don't want to make a graph for this, and I don't want to go to Desmos or any other software to figure it out. All I have is my little Sharp calculator or whatever, my Casio, and I have time for graphing. So logarithms is the way to do it, and I'm going to teach you how to use logarithms to motivate you to learn how to use it. Because next week, we will answer this question with different numbers, and we'll answer with logarithms, and then you can appreciate why logarithms are so useful. So anyway, for this one here, after guessing, you find that t equals 30 years. So the answer is t equals 30. It's not exactly 30, but we have to round up to the nearest year. How did I get 30, Shaquille? I guessed. I guessed, my dear friend. I guessed. It was not fun. Would you like to guess with me? Oops, I'm trying to put a table in here. Here's my table. All right, so let me demonstrate here, right? Can someone type this on your calculator? What is 1.042 to the 10? I'm trusting your calculator skills. In the chat, what's 1.042 to the 10? What do you get? Okay, We're trying to get 3.4. Thank you, guys. Our goal is 3.4 here. See the 3.4 right there? That's what I want to see here. I want to see a red number that's over 3.4. Let's try 20. What is it for 20? Okay. What is it for, now, I'm going to cheat. I'm not going to lie to you guys because I already know the answer. What is it for 29? $3.3 what? Can you give me an extra? Is it 3? Is there a 0 there? What's there? Thank you. And what is it for 30? There it is. You see how it passed? You see how you passed the finish line, Shaquille? You see how you passed the finish line now? You got past 3.4? That's the way you do it. Not fun. Not fun, my friend. That's what I did. Okay? For those of you that are like, do I need to make a table here? Don't worry. I'm going to show you a method next week where you don't have to guess. Because guessing is not fun. Oops. Guessing is not fun. And you can also do a graphical solution here, but I'm not interested in showing you graphs of this right now because we got other stuff to talk about. So we're done with the main part of the lesson on exponential functions. So now we're moving into the logarithmic functions, or what a logarithm is. So what I'm going to do now is I say we take a break until 11, and then I'll teach you about logarithms, some of the basics, so that we can finish up today's lesson. So today's lesson, like I said, there is no quiz. It's straight up lecture, 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 practice, practice, practice for 3 hours. So go take a break, re-energize. I'll see you in 10 minutes.